Today on the Skid Factory, we're throwing Grandad in the bin and going EFI. Love me an old Datsun.
You like them?
Yeah, man. My second car was a Datsun.
What'd you have?
Actually, my first car was a Datsun as well.
Yeah?
I had a B10 Datsun 1000 first car. Second car, 510 1600.
You're a bit of a purist, Alan.
I am pure. I'm pure as the driven snow, mate. Woody and I have taken a bit of a road trip today down to Cleveland Exhaust, the Hoff's workshop. And we've got big Timmy here from Crimp My Ride. We're going to do a bit of a Datsun thing today. We're going to get pure and we're going to work on a Datsun with an L-series engine in it.
The plan today, we're going to convert this car from carburetors to EFI. So we've got some individual throttle bodies to install. We've got a distributor replacement crank angle sensor to install, which makes the magic happen. We're putting on a Haltech ECU, a EFI fuel system to make it all run. So we're hoping to get all this done in one day. That's the goal.
Not only are we doing that, but we're going to do it in stages, so we get to see how much power it's got as it is with the twin Webers and the electronic ignition. Then we're going to drop in the distributor and we're going to leave the carbies on there. We're going to run the distributor with the Haltech with no fuel control. We're going to see what gains can be had from just replacing the distributor and having full ignition control, which is very important. We should be able to see good gains from that. Then we're going to take the carbies off and put the bike throttles on with full engine management, tune it again, see what gains we get from that. So it should be pretty interesting.
So the engine in this car is an L20B. Datsun 1600s or 510s typically came with a 1.6 litre. Some of the Japanese Triple S's had a 1.8. This has had a 2 litre retrofitted. The 2 litres came in Australia in 200Bs and Bluebirds, so in the late 70s, 80s cars. This engine, we don't know a lot about the internals of this engine. We know it's got a bigger cam. We know it's high compression. It's actually quite a healthy motor. It runs really well. The carbies can make life a bit difficult, so we're hoping to remedy some of those problems. The L-series that Datsuns have made, they made these from 1967 through to 2002. So these were a long-running engine for Datsun. What's that? 35 years. They go from 1.3 litre 4 cylinders all the way up to 2.8 litre 6 cylinders. So the Nissan 6s in patrols, Z cars, a whole bunch of different things. They had the L series, a very popular engine. They ran them for years. Mechanically, they're all pretty similar. They all look pretty similar. The 6 cylinders basically have 2 extra cylinders on the end of them. Everything else is very much the same. They're what they call a Siamese port motor. So that means the intake and exhaust is on the same side, which makes them a little bit difficult to work on at times. Australian cars are fine because you've got the brakes and steering on that side. The American L-series engines, it's pretty busy on this side of the engine bay. You've got brakes, steering, intake and exhaust all on one side. We're lucky enough that this is a right-hand drive, so we don't have those problems. Other things to know about this car, this is a 1971 model. It has a little bit of a history. It used to be like a road race rally car. It's owned by a good friend of mine named Mick. Mick's had the car for a little over a year. He has had a lot of Datsuns over the years. This is his next project that he's working on. So Mick spoke to me about putting EFI in the car. He wanted some improved reliability. He wanted it to be an easier start. He's going to drive his family around, so he doesn't want it to let him down while he's got his family in the car. So we thought we would have a go at installing some EFI.
So these engines would originally have had a points ignition system, pretty standard for 60s, 70s. This one's been converted over to an aftermarket type of electronic ignition. Probably sometime in the 80s, it was quite popular for that to happen. It's got a Bosch type distributor in it. They had two different ones in them, Hitachis or Bosches. So the advantage of changing over to electronic ignition is, for one, the coil runs on 12 volt all the time instead of having a drop resistor that drops it down to 9 volts, which is like it's basically there to protect the points from burning. Although electronic ignition is a great improvement over points, it still has the limitations of weights and springs, and it's can only be mapped in a certain way mechanically, whereas a fully programmable ignition system is a big advantage, and Timmy will explain why.
Today we're hoping to substitute this distributor for a crank angle sensor. That sensor will feed engine position information to the Haltech computer we're using, which will fire 4 individual coils directly. Using the computer, that allows us to map ignition in an infinite way. We can map ignition conditions based on RPM or throttle position or manifold pressure. That gives us way more scope to control ignition over what the humble 80s ignition is capable of doing. Our first step is going to be to substitute the distributor, and we're putting individual coils on the car, and we'll just see how it behaves after that, and we'll take note, and we're curious as to that outcome on the dyno, and from there we're going to then substitute in the EFI.
This is the Hoff. He's going to run her up on the dyno now. He's a big guy, but don't worry about it. Squeezing him into the Datsun. He runs a 7-second KE20 Corolla, so he's used to jamming himself in fast cars.
Scott has strapped the Datsun down onto the dyno and is setting up the tacho interface to get an RPM signal for the dyno graph. Once he's done, Alan and Tim check the timing to make sure it's bang on before doing a base run.
We've done a couple of baseline runs to see what the car's making. It's pretty consistent, 120, 123 horsepower at the wheels, which is pretty right for the mods that the engine's got, enough to get an old Datsun moving. So now we're going to see what we can get out of it with some ignition control. The AFR's pretty patchy, but it's carby, so what are you going to do?
This is the crank angle sensor distributor replacement we're putting on the car. It's something that I've developed to help people do EFI conversions on these old engines. It's compatible with 4 and 6 cylinder motors and sequentially capable on 4 and 6 cylinders. It has a 2-tooth pattern inside it with 2 reluctors, so that's what makes it sequentially capable.
So this pattern that this crank angle sensor runs, it's 24+1, so there probably wouldn't be an ECU made that couldn't read this. It's a really basic trigger that has everything you need, but it's also very simple for any ECU to read. So even if you've got some low spec ECU, if it can't read that, then throw it in the bin, because it's a really reliable and easy to configure trigger pattern. Timmy's very prepared, so he's already made up this coil setup. It's just LS coils, as you know, they're a good thing, easy to get, do the job, heaps of spark power. So that's got a bracket and everything that he's made to fit it up to the engine. But when we remove the distributor, we've also got the Elite 550 and a Crimp My Ride special fuse box. The whole works all ready to go. Just got to be installed in the car, and just batteries, positive, negative, ignition feed connected to it. And then we'll be able to run it up again.
This distributor is electronic. It sends signal to this module here. This module takes the signal from the distributor and then feeds signal back in to the coil, which then drives, which it does the spark. Inside the distributor, once you take the cap off, you'll see the center post that comes from the coil, and then you've got these other 4 posts here. This center post, the one that's spring loaded, goes into here, which is the rotor button. And as the engine rotates the distributor, it then distributes the spark to the cylinders in the correct firing order. This distributor rotates anti-clockwise. So as the engine's rotating, the distributor goes anti-clockwise, but the engine goes clockwise, and the gears make that possible. We're not having any issues with this distributor at the moment, in this module. We're hoping to improve it though by substituting this out with EFI. I've already undone the bolts to remove the distributor, so it just basically pulls straight out. Once the bolts are removed, on the bottom of the distributor, you can see the keyway, which engages on the all pump drive. Now that just means you can't put it in backwards. You can put it in the wrong position, but you can't install the distributor backwards. To install the distributor, we first have to install the housing adapter, and that will allow this crank angle sensor core to be adjustable. It's simply 2 Allen key bolts, and it pushes into the motor like this, and you just drop the Allen keys in. It's actually quite straightforward. Once the housing adapter is installed, it's just lining up this keyway with the distributor drive in there. We can clock it, but the most important part is that goes on properly. It won't go in at all otherwise. So once you find it, it will press in. We have the crank angle sensor installed. It's now engaged on the distributor drive. So as the engine rotates, the crank angle sensor will rotate as well, generating a signal. The ECU we're using is a Haltech Elite 550. It's sequentially capable on a 4-cylinder. It'll allow us to do everything we need to for this conversion. I've already wired and mounted the ECU onto a bit of plate. We're just going to push the wiring harness through the firewall, and we can get things connected.
Tim's Crimp My Ride loom is ran out into the engine bay and connected up to the crank angle sensor and the individual coils.
Bit dark there, Alan.
Got the coils fitted up, got the crank angle sensor connected. Timmy's just hooking up power to the little board that he's got in there with the relays and stuff on it with the ECU. And then we'll be ready to fire it up on the new crank angle sensor and coils. So fire up the ECU with the ignition switch. So we're connected. You can see the trigger page here where we're using a Toyota 3SGTE trigger type, which is listed in a drop-down box on a Haltech Elite. So what we got to do is just change this TDC offset angle until we get the spark on TDC 1 correct. So we have to go into ignition and put lock mode on to always. 10 degrees. Is 10 degrees a good thing? Timmy says 0 is easier to see. It doesn't really matter where you got it as long as it's easy to see on the actual crank pulley. So we'll set that up. We'll go OK. Then we can go into diagnostics and see if our crank sensor's picking it up. So we've got trigger synchronization state, synchronization level, and errors. So then we just crank it, and we should see fired straight up. So obviously it's close. You see it's running full, no errors. Perfect. basically just need then to change the trigger angle so the timing is correct. So I'll get Timmy to hook up a timing light and check timing, and then I'll just change the angle until it's set at 0 where it's supposed to be. Good to go, Timmy?
Good to go. We've adjusted it and we're seeing 0 at the motor, 0 at the ECU. So the two are synchronised together with the engine.
Okay, so we just had to change the offset angle 20 degrees and it's pretty right. So that's pretty easy. You don't have to actually touch the distributor or anything. You just do it on the ECU. So now I can go back and change the lock mode and disable it. You can hear the motor pick up. That's because it's going back to the ignition map now, rather than being locked on 0.
With a set of detonation headphones, the Hoff gets to tuning the ignition map. Starting off at idle, he then slowly adds more and more load onto the engine, adjusting the map as he goes. The headphones allow him to hear any detonation coming from the motor, so the Hoff knows he's pushing the little Datsun too far. The Hoff reads data after each run. This allows him to see the differences in the changes that he's made and can continue to adjust the map accordingly.
So Hoff's been on the dyno doing a bit of ignition tuning. We set some filter levels and stuff so it's, the crank trigger picks up properly all the way through the rev range, which you need to do with reluctor stuff. We've picked up a little bit of power. That's about all we were expecting. You're not going to pick up a lot of power just by changing the ignition system. This is more just to get it right before we put the EFI on. So that'll be next.
We're about to fit the throttles. The throttles are actually off a motorbike. They're Suzuki Hayabusa throttles, so GSXR 1300. They've got bigger injectors in them. They're Honda S2000 injectors, which are a direct replacement. They're like 350 cc's, I believe. So that's next. They're a set of throttles that I've been working on with a manifold that bolts to the engine. Once we install those, we'll go through the process again of having the fuel map tuned to accompany the ignition map that's just been done.
The webbers are pure, but they are also smelly and leaky, so they are removed to make way for the new quad throttle body setup. Off comes the accelerator cable, vacuum lines, fuel lines and inlet manifold nuts, and Al places the carburetors in a safe spot. A coolant temperature sensor is added so the Haltech ECU can see the coolant temp of the engine. In addition to the coolant temp sensor, there is also an air temperature sensor that is mounted on the throttle body plate. An air filter covers this, but for today, we're leaving it off. The accelerator cable is modified to suit, and Al makes sure it's going to do its job.
Board.
The final piece of the puzzle is the fuel line, which is fed by a single external fuel pump that Tim had set up ready to go. This also has a fuel pressure sensor so the ECU can see more data.
We got the Hayabusa throttles on with the custom inlet manifold. Timmy pre-wired everything because he's that kind of guy. Everything just plugged in. We screwed a coolant temperature sensor into one of the spare bungs on the thermostat housing. Jerry rigged up a fuel system, put a throttle cable in that is operating this properly, and we're nearly ready to go. What's now, Timmy?
Next we need to turn the injectors on. We were ignition only before. We'll be turning the injectors on and putting a fuel map in it and tuning it accordingly.
Not my car, are you, Alan?
All right then, let's go.
The Hoff is back in the driver's seat and is ready for more tuning. With the ignition map accounted for, the Hoff is now tuning the fuel map. Again, starting at low loads, the Hoff reads his data and makes adjustments to suit. There is no base map in the ECU, so he's starting from scratch. Luckily for us, Scott's an absolute gun, and it doesn't take long until the little Datsun is happy and the L20B is performing like it should.
Datto's had a big day. It's gone from twin Webers with a distributor to twin Webers with a programmable ignition system to Hayabusa throttle bodies with full engine management. It's had a few plays with in between, lots of dyno runs, and it hasn't missed a beat. It's a little gem, this one. So we picked up 10 horsepower, which is pretty bloody good for an NA engine with virtually the same setup. And that's pretty much just in fine tune, being able to fine tune the air fuel ratio and the ignition system. So it was very well tuned before on the Carby, which, you know, that showed up in the first dyno run. It was quite a good achiever as far as an NA 2-litre engine of this vintage. So now what, Timmy?
Next for this car, I think we'll be putting some road Ks on it. Mick plans to get out there and do a lot more driving with it. As shown on the dyno tuning, the mid-range drivability and the throttle response is well improved. He's got better air fuel ratios across the board. So it's his fuel consumption, which is a factor, is going to be a lot better. The engine's working more efficiently compared to how it was before. It was good before, and now it's way better. It's great. Peak power doesn't tell the full story as to how much better this thing is working. So we're really happy. Mick's delighted that it's making more power and that it's making better noises and more noises.
Yeah, it sounds terrific on the dyno. It's just different now.
So yeah, it was a really good day. Big day, lots of work, lots of spanner work on the car, but the car was perfect. We didn't have any issues mechanically with the car at all. Scott did an awesome job with the tune. The guy's a wizard, just made it run great. He started, there was no base map involved. There was nothing in the ECU. He did everything from scratch, and the car runs awesome. You lean in, you hit the key, it starts and purrs. It's like a new car. It's pretty remarkable, actually. We're so happy with how it's working.
I don't think we'll be needing this anymore, except for car park meets, maybe. Yeah, we better keep it.
So Tim, rumour has it that this Datsun might be a little bit better than yours.
There's some things about it that are better, yeah, you might say that.
Is that because it's got 4 doors instead of 2?
4 doors, 4 doors certainly makes it easier to... It's a family show, I can't say that.